Let us understand the properties of a kite. Before we jump into the math, let me tell you a quick story. There was a student, let's call him Alex. One windy afternoon, Alex tried to fly a homemade kite. But instead of flying, the kite kept spinning, flipping, and eventually crashing to the ground. He got frustrated, but when he examined the broken kite, he realized something. The sticks inside weren't placed correctly. The sides weren't equal, the angles weren't balanced, and the diagonals didn't meet in the center. That moment made Alex wonder, so what makes an actual kite stable? That question led us to today's topic. Today I want you to understand the parts and properties that makes a geometric kite work. Because once you understand the structure of a kite, you'll be able to solve or analyze real object, solve geometry problems faster, and even see patterns in design and engineering. So, what is a kite shape? A kite is a quadrilateral with two pairs of equal adjacent sides. When Alex compared his kite to a real one in a store, he noticed something important. The real kite had a longer wooden stick running top to bottom and a shorter one across the middle. These two sticks were in the same length, but they intersected perfectly at the right angle. Here's the point. I want you to remember that the diagonals of a kite always meet at 90 degrees. This perpendicular intersection is what creates the shape stability both in geometry and in real life objects. In Alex's faulty kite, one side was longer than its adjacent side. That unevenness made the kite tilt to one another, making it impossible to stay up. So the point is, always identify the two pairs of equal adjacent, and that is the property number one. Two pairs of adjacent equal sides. This will help you quickly determine whether a quadrilateral is truly a kite or not. When Alex tried to tape his kite back together, he noticed two angles that looked bigger and almost identical. He didn't know it then, but those angles were supposed to be the equal obtuse angles of a kite. The point is, in this property, a kite has one pair of equal opposite angles, usually the wider obtuse one. One pair of opposite angles are equal. That's a property number two. Recognizing these angles helps you classify kites even when the sides lengths aren't given. Alex saw that the horizontal wooden stick, the shorter diagonal, was connected to two sides of equal length on both ends. This created two identical looking triangles. The point is, in the property number three, the shorter diagonal of a kite always forms two isosceles triangles. And this will help you analyze angles and sides quickly when solving problems involving triangles inside a kite. Meanwhile, the longer vertical stick in a kite created two triangles that look like mirror images. This is because the diagonal is the one dividing the kite into two equal halves. Remember, the longer diagonal creates two congruent triangles, the side-side-side theorem. And this fact is powerful in proofs and problem solving because congruent triangles give you equal angles and equal sides immediately. When Alex measured the sticks of the store bought kite, the diagonals were at perfect right angles, like a plus sign. Kite diagonals always intersect at 90 degrees. Knowing something is perpendicular allows you to use the right angle or right triangle rules, simplifying many computation. That's a property number 5. Property number 6, when Alex realized the long stick cut the shorter one exactly in half, that's why the kite weight was properly distributed. Always check that the longer diagonal bisect the shorter diagonal. And that would lead us to the property number 6. And this will help us solving for missing lengths in geometry problems. In property number 7, Alex noticed the vertical stick went straight through the top and bottom angles, dividing each into two equal parts. The longer diagonal bisect the pair of opposite angles. This helps when solving angle measures with algebraic expression. So let us define what a kite is. A kite, again, is a quadrilateral with two pairs of congruent adjacent sides, but no opposite sides are congruent. So in the next part, we're gonna continue the finding the this applying the theorem or the first given that we have here. This is the S or the STIK kite. Okay, and we're gonna find the missing angle here. Okay, so see you in our next part of our discussion.